timing. Then these clock pulse are given to this IC. See, we have a habit of looking the clock pulse like this. Okay, processor do not require this kind of clock pulse. It requires the edge trigger clock pulse. So these sharp edges are doing all the business. Okay, not this much portion. So you can have a capacitor connected like this. Okay, and the clock pulse goes like this, and then here it is the generation. Okay, or RC circuit is utilized to generate the sharp edges. Okay, so it is like a filter or circuit. So the moment the sharp edge goes, the charging begins faster, but then it drops slowly. Okay, and thereby it converts the sharp uh, this thing. So timing generation will control this kind of operation to create that square wave pulse into the sharp edges. You have a watchdog timer, so it is talking with this fellow. So here you can see a kind of a hardware or software control watchdog timer, okay, which is not mentioned here how it is controlling. Power on reset is there, uh, so it will reset the circuit. Oscillator startup timer uh, and power up timer. Okay, so instruction decode. So if you set up some timing, that after that it has to power up. Your mobile phone has got capability that you can tell the mobile phone in the evening, say after 9 o'clock, uh, it will power off itself, and in the morning 7 o'clock it can boot again. So in that case it will store maximum battery. Okay, one thing. uh, Even if you see, if you switch off your mobile phone, but if you set up the alarm, okay, what will happen that in the morning the alarm will ring. This is the operation which is programmed inside the mobile phone. So when you power off the mobile phone, but if you have set some alarm, then what will happen in the morning, that alarm will start ticking. So it is acting like a clock. So whatever timing you set up, and then you, if you set up the clock pulse, uh, you are getting that. Okay. So these are the advanced features available with different processors. There is a this W register, working register. There is a ALU. There is a MUX multiplexer. Okay. So instruction register, from where the instruction will come, then it will be decoded and controlled. Okay. At the same time, it goes into the MUX, and then it reaches to the ALU, and there is a working register utilized to do the mathematical operations, right? So in previous case there was a register B used to do additional arithmetic operations. Here that is replaced by the working register. Okay, so this is what we have to now understand. Then there is a status register. So it was a like program status register, what is happening and how. FSR register, uh, and here are the ports which are communicating with the external devices. Port A, port B. As you go with advanced PIC microcontroller, you will have a port C and port D. Okay, so this may be like port A is communicating with the external memory. It fetch the address, and then it transfers the data. Then some additional functions were associated with port. So in previous case we were having port 0, 1, 2, 3. Port 0 and port 1, port 2 are used to communicate with the memory, external memory, and port 1 and port 3 used to have a different operation, timing control, counter, and serial communication, interrupt, receiving interrupt. So similarly, on the same analogy, these are functioning. Only benefit is that the operation in microprocessor, there are no ports. In microcontroller, there is a application of port which protect the processor. Okay, so unless and until you activate these ports, enable the ports, you will not transfer the data. So that is the one thing. Okay. So this is a little bit introduction of PIC microcontroller. And then higher versions, as I told you, port A, B, C, D. Now you have all this. So here you can see the PIC 1662. So it was 61 only. 61 is the basic one. 62, beyond 62, you have a additional port C, port D, port E, and then they are controlling different communications. So PSP 0, 1, 2, 3, 7. So this is a parallel communication. You have a read write control. Uh, okay, so it is read write control which is active low. Otherwise, it is RE0, RE1, RE2. So ports will have their own flags. When the flags are set to 1, uh, they will work for this. If they are set to 0, then they will have a different function. Okay, so that's why these oblique values are there. Okay, so and then when you say read, then it can read or it can write. So this can be a bidirectional thing. This will be controlled by the flag values or the port condition of it. Okay, so this is parallel straight through port is an additional feature available with this. These are the serial communication. Okay, so anyways, um, I would like to give you a
Yes, sir.
small exercise. I'll stop recording first.